Hello all, warm wishes to everyone. Welcome to my video. My name is Dr. Ayan Devnath. I am an IIT Delhi alumni. I have total 8+ years of experience in the field of data science and AI. I have already done few videos on introduction to SVM and also maths behind the SVM. Now in this video I am going to explain you kernels and different types of kernels in SVM, and these are very important concept because kernels we have to use in our practical cases, because in practical cases we don't find this kind of data which is linearly separable, right? But what we find is that there are data which are very complex and which are non-linearly separable, because here you can see that there is no way that you can linearly separate. If you draw a hyperplane like this, then what will happen? It will have a maximum number of misclassification points, and that is not allowed. So we will not get the best suitable hyperplane. And if you have to get a kind of hyperplane, then what happens, like if you draw a hyperplane like this, then it will separate, then it will rightly classify the points, because this has blue points around this and here there are green points, right? So it rightly classifies, but this is not linear, this is non-linear. In the same way here, if you draw a hyperplane like this, then you will get 50% accuracy. So this is not a good hyperplane. So what you should do, you should have a hyperplane so that it can classify these 2 points, but it will be in higher dimension. So here comes the concept of kernel functions. So what is kernel function? Kernels are mathematical function or operation which helps to transpose the data, from lower dimension to higher dimension. Right, this is the definition of kernel, that it is a mathematical function which is used to transpose data from lower dimension to higher dimension. Now let me explain you these things. We have in 1D, in one dimension, we have data like this. This belongs to one class and this belongs to another class. This is not linearly separable. Now what we will use? We will use a function. So say this is y and this is x-axis, then on x we will have a function which is called kernel. Kernel function, we will use a function so that we can project this data to above or higher dimension, right? If we have a function like x square which is taking the squaring of the value, so what will happen if you take square of these values? So x square, where it will go, right? It will go like this. We are projecting this thing. We are projecting this value to a higher dimension, right? And this will be projected as like this. Okay, so what will happen, that we will get another function where we can easily separate. If I draw these things in a better way, we can have a hyperplane like this, which can clearly separate out these 2 points, and this is in 2D. So what we are actually doing, from 1D we are transforming it to 2D. So when the data was in 1 2D dimension, then at that time we are not able to linearly separate those data. So we take the help of kernel functions, that is kernel tricks, and by that, using that trick, we are transforming the data from 1D to 2D. 2D is the projection in higher dimension, and when we take the data in higher dimension, then we can use a hyperplane to classify them. Right. Now we are using polynomial kernel to transpose the data from 2D to 3D so that we can have a hyperplane to classify these points. Now I will show you how a polynomial function works. Say for example, this is x1 axis and this is x2 axis, and we are having the data like this. So we are having the data like x1 and x2, and we are having this y value. So what is y? Y is function of x1 comma x2. Here what we do, we take the x1 transpose into x2 plus of 1 to the power d. This is a formula of polynomial kernel function. So what is x1, x2? x1 and x2 are points in defined axes. Okay, like we take x and y in 2D. Okay, so this is x1 and x2. What is x transpose? This is transpose. Now what is this? What is this dot? Dot is dot product. What is this one? One is unit vector, identity vector. The D is dimension. Dimension of this polynomial function. If we take 2, this is square, that is in 2D we are taking it. So if we take 5, then we are taking it 5 dimension. So D determines in which dimension, in which higher dimension we are taking it. x1, x2, dot product of x1 of x2 plus of 1. And we know that what is dot product? Dot product is multiplication of x1 into x2 plus x1 into x2. Right, I have already explained. Then this multiplied by this in plus this multiplied by this. Okay, so we can write it as x1 into x1, okay, plus x1 into x2. Now coming here, x2 multiplied by x1, that is x2 multiplied by x1 plus x2 multiplied by x2. Okay, we can write it as x1 square plus x1 into x2 plus x1 into x2 plus x2 square. So here we are taking into 3D. So in 3D, how it will look like? Say this is x1 square axis, this is x2 square axis, and this is like x1 into x2 axis. Okay, so while we are taking these things, what will happen? X1 square, so it will look like this. And we have the points, these points x1 into x2, x1 into x2 will be like this. And thus we can easily separate these 2 points using a hyperplane. What is a hyperplane? Say, and thus if we see that we have points x1 into x2, x1 and x2, and we are taking it as x1 square, x2 into x1 and x2 square. So from 2D we are taking it to 3D. So in 2D we are not able to classify the point, so we are taking it to higher dimension from lower dimension to 3D, and we can easily classify this point. And thus it shows that when we are using polynomial kernel, we can take it from lower dimension to higher dimension, and thus we can classify the points. I will try to give you an example. Don't laugh. Okay, say for example, here you see all this point on this black is of say 1 class, and all the points, imagine it, okay, there are few points in this blue space, and this belongs to another class. This is similar to like this. Now while we are doing polynomial function, so what happens that we are taking it out. Okay, right, so from 2D, here it is 2D, we are not able to classify it, and we are taking it out Okay, we are taking it to higher dimension, so it can classify. Now you will find the black point here and the blue point is in higher dimension, and thus we can able to classify using polynomial kernel function.